There is a place where the river narrows, where walls of ancient basalt rise on either side, and the Columbia River pushes forward with a force that has carved this landscape for 10,000 years. The water is cold and green and relentless. Stand at the edge of that gorge today, and you will feel two things at once, something primordial and something unmistakably human. That is Bonneville Dam. And its story begins not with concrete or steel, but with desperation, and with a nation that refused to surrender to its own collapse. The year was 1933. America was broken in ways that statistics cannot fully capture. 1 in 4 workers had no job. Families were losing farms that had been in their hands for generations. Banks were closing. The future had become something people were afraid to discuss. Franklin Roosevelt arrived in the White House carrying a different idea, that government could act, boldly and at scale, to rebuild what the economy had destroyed. The New Deal was not simply a relief program, it was a declaration. And nowhere did that declaration take more dramatic physical form than along the Columbia River, 40 miles east of Portland, Oregon, in the dramatic sweep of the Columbia River Gorge, where wind and water had been doing their slow, magnificent work since the last ice age. Engineers and planners had understood for decades what the Columbia could offer a growing nation. In 1929, the Army Corps of Engineers published what became known as the Columbia River 308 Report, a sweeping methodical recommendation for 10 dams along the river system, designed to provide flood control, hydroelectricity, navigation, and irrigation across the Pacific Northwest. It was visionary work. It was also ignored because there was no political will and no money to act on it, until the Depression changed both. With funding secured from the Public Works Administration in 1934, 2 monumental projects were launched simultaneously: Grand Coulee, positioned further upstream on the Columbia, and Bonneville, here in the gorge, where the river had once churned and roared through the Cascades Rapids, a natural barrier that had challenged river navigation for as long as people had tried to move goods along this corridor. 3,000 laborers reported to the site. These were men drawn from relief and welfare roles, men who had been waiting for something, anything, that resembled honest work with honest pay. They earned 50 cents an hour. They worked in non-stop 8-hour shifts, around the clock, through rain and cold, and the particular exhaustion of men who know that stopping is not an option. The Columbia River Gorge is not a gentle place to work. Wind funnels through it with unusual force. The river itself is moody and unpredictable, but these men kept working because they had come too far and waited too long to stop. Before a single shovel broke ground at the river's edge, the Army Corps of Engineers did something that revealed just how seriously they took this challenge. They built one of the largest engineering scale models in history, a precise physical replica of the proposed dam, the surrounding river channel, the islands, and every major structural component of the project. Engineers could test water flow, study sediment behavior, and identify problems before they became catastrophes. It was an act of scientific humility as much as engineering ambition. They knew what they did not know, and they built the model to find out. The fundamental challenge was the Columbia itself. Wide, deep, divided at this location by Bradford Island sitting in its middle channel, the river was not the kind of obstacle you could simply stop. It had to be managed, redirected, and outsmarted. The engineers began by constructing cofferdams, massive temporary barriers built from rock and fill material that blocked half the river's flow at a time, pushing the current to one side while workers on the other side could reach dry, workable ground and dig down to the bedrock foundation the structure would require. Then they would switch sides. It was a methodical, carefully sequenced process that required constant vigilance, because the Columbia could rise without much warning, and a cofferdam overwhelmed by floodwater was not an abstract engineering problem. It was a human emergency. On the Oregon side of Bradford Island, engineers constructed the first powerhouse and a navigation lock. On the Washington side, they built the massive spillway that would manage the river's flow when water levels rose. At the time of its construction, Bonneville was the largest water impoundment project of its kind in the United States, engineered to withstand flooding on a scale that no American dam had previously been designed to handle. The navigation lock, when it opened in 1938, was the highest single-lift lock in the world, capable of raising or lowering river vessels a full 60 vertical feet within a single chamber. Barges, steamboats, and commercial craft that had once been stopped by the Cascades Rapids could now move through the gorge without interruption. The old Cascade locks and canal, built back in 1896 to navigate those same rapids, were swallowed entirely by the reservoir that formed behind the new dam, a body of water that came to be known as Lake Bonneville. Power generation began in 1937, before the project was fully complete. Commercial electricity began flowing from the dam in 1938. Roosevelt had fought hard to ensure that this power would belong to the public. Private utility companies and their advocates pushed back fiercely. They did not want the federal government in the electricity business, and they argued against what they called government interference in private markets. Roosevelt held his ground. In 1937, he signed the Bonneville Project Act, creating the Bonneville Power Administration to distribute the dam's output across the region. The BPA maintained a rate of $17.50 per kilowatt year, roughly 0.2 cents per kilowatt hour, for the next 28 years. It was electricity so affordable it seemed almost fictional. And that cheap, abundant power did not merely light homes and run refrigerators. It built an industry. Aluminum smelting is one of the most electricity-hungry industrial processes in existence, and suddenly the Pacific Northwest had more power than it had ever imagined. A powerful aluminum industry took root along the river, fueling manufacturing and, when the Second World War arrived, fueling the production of aircraft and military equipment that the Allied effort depended upon. The dam that was built to save a region from poverty ended up helping to win a war. In 1974, construction began on a second powerhouse on the Washington side of the river. The project required physically widening the river channel, a feat that created an entirely new island, Cascades Island, between the new powerhouse and the original spillway. The second powerhouse was completed in 1981. Together, the two powerhouses now carry a combined rated capacity of 1.2 gigawatts, generating approximately 5 billion kilowatt hours of electricity every year, enough to supply power to nearly 500,000 American homes. But Bonneville's story has never been only about power generation. The Columbia has been a salmon river since long before any engineer drew a line on a map. The dam fundamentally disrupted the ancient migration routes that salmon and steelhead had followed for millennia. The response was the fish ladder, a long, stepped series of water channels built into the dam structure, allowing fish to make their upstream journey to spawn by swimming through a passage designed specifically for them. During spawning season, visitors crowd the viewing windows at the dam to watch thousands of fish move through the ladder in a ritual as old as the river itself. The largest fish hatchery in Oregon sits directly beside the dam, supporting fish populations and drawing tourists who come specifically to witness that ancient migration continuing against all the odds. California sea lions, drawn by the sheer abundance of gathered fish, are spotted regularly near the dam's base. White sturgeon, once blocked from upstream spawning grounds they had used for centuries, still populate the waters below the dam in healthy numbers. The Bonneville Dam Historic District was designated a National Historic Landmark in 1987, a formal acknowledgement by the nation that what was built here during the darkest years of the Depression represented something worth preserving and remembering. Those 3,000 men who worked through the cold and the rain for 50 cents an hour built something that outlasted the crisis that created it. They built something that is still running, still generating, still carrying the Columbia's power into the homes and lives of the Pacific Northwest. The river still runs, the fish still climb, and somewhere in every kilowatt moving through the grid today, there is an echo of those long shifts, those tired hands, and that extraordinary refusal to accept that the future was finished. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.